So we're going to do bonding today. There are three types of bonding. There are ionic, at your high school level, ionic, covalent, and metallic. Today, we're going to just do ionic and covalent bonding, and metallic will be for another day. Now, with ionic bonding occurs between a nonmetal atom and a metal atom. However, with covalent bonding, it occurs between a nonmetal and a nonmetal. So we could look at two examples for each of them. So we have ionic, where it can occur between sodium and oxygen. Sodium is a group 1 element, so usually you see it like this. Oxygen is a group 6 element, so you would see having a charge with it. These charges simply mean that if you have plus, means that the species has lost electrons, and if you have this minus, it means that it has gained this amount of electrons. So a plus means, well, for this, since you have a plus, you have lost 1 electron from sodium. And with oxygen, since you have a minus, you will gain 2 electrons, right? So that makes your whole attempt to do this question much easier now that you know what the signs mean, right? So when we're dealing with bonding, usually we do it in the dot and cross method. So you would have, and that is known as Lewis dot and cross. So for sodium, maybe you learned to draw sodium with the concentric rings, and you know that sodium has 11 electrons and whatnot. But to make your life easier, you no longer would have to have an idea of how to do dot and cross, Lewis dot and cross. All you would have to do is just take into account the valence electrons. And with sodium, you know that you have 1 valence electron. However, with oxygen is a group 6 atom, so it would have 6 electrons in its valence shell. So since that is the case, you would simply move over this sodium right there, and you would you would add another sodium species so that you would have the fulfillment of the octet via the movement of the other sodium electron to achieve that. And this in return would give you something beautiful called your reaction expression, where you would now say that 2 sodium ions were needed to complete oxygen's valence shell. Therefore, we have 1 oxygen, and since it gained 2 electrons, now has an oxidation state of -2. And then your species now will be such that it is, because you needed 2 of these. Basically, when you have this, your your expression would be O2 minus. Remember, when you're writing it, this goes here, and because this is a 1, this will go down here, and you'll be left with Na2O2. The same thing for another example is such that you could try aluminum. So here we have aluminum. So aluminum is a group 3 metal. Therefore, we would have an oxidation state of 3+, which means what? It gives away its 3 electrons. And say you want to react it with chlorine. So aluminum, you're making aluminum chloride. And aluminum chloride, so chlorine is in group 7 and it has 1 electron to gain. It has 7 electrons and only 1 electron to gain. Therefore, when you're drawing out your Lewis dot and crosses, aluminum would have 3 electrons, whereas chlorine would have 7. And this is very much the same way that we attack the other problem, because you only fill in 1 space. For chlorine to make 8, you would definitely need to have 3 chlorines present, right? So you would have to have 3 chlorines present so that you can get rid of all of the electrons around aluminum, which is pretty easy. Well, I shouldn't say easy because it takes practice for you to at least understand what is going on. So I'd say it's a level 1 and you can learn it. It's fun. The next electron goes there and the next electron goes there, right? So basically what you have left, you say you have 3 electrons going from aluminum, therefore aluminum is now Al3+, right? And you have 3 chlorines, 3 chlorides, right? The formation of 3 chloride ions, right? And then therefore, because of that, this number here will go here to the end there. And because this is a 1, this will go here. And then you would have AlCl3, AlCl3. And that's a wrap for ionic bonding. With covalent bonding now, we're going to look at water. Water is peculiar, water is fun, water is what we drink all the time. Now, hydrogen is a group 1 nonmetal, right? And we could react it with oxygen. And oxygen has 6 electrons like we did earlier. 1, 2, 3, 4, 5, 6. Therefore, you would obviously need 2 hydrogens to complete the octet here. However, because they're nonmetals, they form shapes. They bond together. There's no giving away of electrons really. They bond together. So instead of having in this case you will see electrons being given away and the formation of the compound like shown here, you would have now a formation of oxygen. You have oxygen forming a bond with hydrogen to fulfill its outer octet. Because remember, hydrogen, it's only the first orbital is fulfilled